Okay, this one they do typically give you a picture of this one. So we have another negative parabola. And it does have to be symmetric to the y-axis for this problem to work. So they usually do give you this picture, okay? So there's my parabola. And we have a rectangle inscribed within that parabola. The base of the rectangle is on the x-axis. Okay, so this is sitting on the x-axis, and then the top corners are touching the parabola. So what that looks like is this. Okay, that's the rectangle we're talking about. Okay, and they want us to find the largest area of that rectangle. Okay, so we know we're going to find, as we've done a million times, we're going to find the area of that rectangle. Then we're going to do the derivative of that area, set it equal to 0, make sure it changes from positive to negative. Okay, well, so then the only thing that's tricky is how do I write the area equation? Well, yes, normally it's x times y, right? Or length times width. Well, how are we going to denote the x and the y? Again, it comes down to putting an xy here on that corner that they share. Okay, that spot right there is xy. I don't know what it is. It's some point, a random point. But that means that this distance here is x, which means this is also x. So my area equation, if I'm doing the length and the width, it's going to be a total of 2x times y. That's my area equation. Okay? Then, as always, make sure you get rid of the y, replace it with this guy. So my area is going to be 2x times y, which is 54 minus 2x squared. The rest of this you've done a million times, no big deal. Okay? Distribute, find the derivative, blah. Sometimes the derivative is harder than at other times if there's a radical or something like that, but that's the main idea. Okay? So you got to kind of know what this picture looks like when you're inscribing a rectangle. Be able to draw that picture, and one of the keys, once again, put an XY right there on that corner so that you can see this goes over X and up Y. Okay, let me say that again. From the origin, we go over X, up Y. So that's a Y right there. Okay? All right, now I'm going to go ahead and finish this problem. Distribute, what is that, 108X minus 4X cubed. Find your derivative, 108 minus 12x squared. Set it equal to 0 and solve. And it looks like we're going to get 2 answers because it's an x squared. But remember, you can only have a positive length. Okay, they want the dimensions of the rectangle. So we get 108 equals 12x squared. Divide by 12, and x squared equals 9. So x equals plus or minus 3 if we were looking at coordinates. But we're looking for dimensions. Okay, so we're going to stick with the positive 3 only. Now, don't forget to actually answer this question. What are the dimensions of the rectangle? This is why I say when you get x equals a number, you got to make sure you know what it represents. The rectangle does not have a length of 3. The total length of the dimension would be a 3 and another 3. So it's a total of 6 in one direction. Okay? And then to find the y, we have to plug it in back up here. So the y would be 54 minus 2 times 9. So again, even though I got that x is 3 and I get y is 36, okay, the actual answer to my question, the dimensions of the rectangle, are 3 going to the right and 3 going to the left. So it's a total length of 6 by, yes, that's a y, and that's 36. Okay? I think they also asked what is the largest area. So they actually want me to multiply that too. So the area would be, whatever you get when you multiply 6 times 36. 216 square units of some sort. Okay, so 2 answers to that one. All right, so key for that one, make sure you draw a good picture. And don't forget you're going x to the right and x to the left. Okay, and that's why your total area is 2x times y for that one. Okay? The next one's just like it. You don't really have to listen to that one if you don't want to do another one just like it, but I'll do it anyway, okay? So this is a semicircle. It's a radius of 3, so it goes over 3, up 3, down 3, 3, 3, 3. It would look like that. Hey, that wasn't so bad. That was pretty good. Pretty proud of it. All right, so that's the equation we're dealing with. And we want an area of the rectangle inscribed within it, just like the last one. So the rectangle would look something like this. So again, from the origin, you're going over X and up Y. The key is still to label that point in the corner. And now this is over X, this is over X, and we're going up a Y. So the largest, find the area of the largest rectangle. So we're maximizing that area. So the area of that rectangle is 2X times Y. And we're going to have to maximize that. The only thing that makes this one difficult or different is just knowing how to draw that semicircle. Okay, and you're going to have a square root problem, so it's a little harder to actually do the derivative. So change Y to what Y equals. And that's about as good as it gets. So that's the only thing that makes this harder is when we do this derivative, we have a product rule and a chain rule. Okay, so now I'm going to do the derivative. So I'm going to do a product rule. I have a 2x and a 9 minus x squared to the 1/2 power. The derivative of 2x is 2. The derivative of this guy is 1/2 9 minus x squared to the negative 1/2 times the derivative of the inside, which is a negative 2x. And those 2's will cancel. Okay. So my derivative will be, I need to make a little bit more room for this. Okay, so crisscross, 2 times square root of 9 minus x squared. And now when I crisscross this, I'm going to have a negative. There's still an x here, okay, and a 2x here. So when I multiply that, I have a negative 2x. And then this guy's going to go on the bottom. Okay, so double check that I did that. I think actually I messed that up. It's 2x times x, so it's a 2x squared. Okay, double check that. Make sure you got that right. And now it's just a matter of getting a common denominator like we always do. Okay, so I'm going to multiply by. Multiply this fraction by a square root of 9 minus x squared over itself. This is kind of messy, I'm so sorry. So what does that do? In the numerator, I'll have a 2 and a 9 minus x squared. Minus a 2x squared all over the common denominator of this. Okay? Distribute, combine like terms. And that's my derivative. Okay, I'm going to double check my math, so I'm going to pause for a minute, make sure we're on the right track. Okay, so find your critical point. Set the numerator equal to 0, and you get 18 minus 4x squared equals 0. Divide by 4. That was an 18, that's messy. And we'd get 9 over 2. Square root it. And x would equal plus or minus, but we'll just keep the positive one. Square root of 9 would be 3 over the square root of 2. Okay? So that's my x going this way. Now I'm going to reread. Oh, by the way, the denominator, if you set that equal to 0, you get that x is 3. And hopefully know that that is actually this point on the circle, or the semicircle, so that's not possible. Okay, so if that's my value of x, let's reread the question, see what they really wanted. They said find the area. So I'm going to need to find the area. I don't really have to find y. I can just use my value of x right here. Okay, so the area will be 2 times 3 over square root of 2 times the square root of 9 minus, square that again, we go back to 9 halves. That ugly answer, I have to clean it up, I'm sure, but whatever. It's that number, whatever it is. Okay? And I don't really care about the final answer. I said I didn't care, but I can't stop. All right, so change the 9 to 18 over 2. 18 over 2 minus 9 over 2 would give me 9 over 2. Square rooting those. Square root of 9 is 3 over the square root of 2. Multiply across and you get 18 over 2 is my final answer. Oh, nope, it's 18 over 2, which is 9. So the area ends up being 9. What a mess. All right, good luck, guys.